This is the decomposition of potassium chlorate, and we want to figure out if we need 50 liters of oxygen at standard temperature and pressure, how many grams of potassium chlorate must we decompose in order to get the desired amount of oxygen? So, given our molecular formula, KClO3 goes to 2 potassium chlorides plus our molecular oxygen. We want to first make sure everything's balanced, and it looks like we got 6 oxygens on the left and 6 oxygens on the right, and two potassiums, and 1 chloride. So everything looks balanced, and that's good. So we want 50 liters of oxygen. And so in order to find this, we go ahead and search in Google, and we go ahead and search the density of oxygen at standard temperature and pressure, just like that. And obviously it's reversed, so it can't see. But we'll get the density of oxygen is at standard temperature and pressure is 1.43 grams per liter. And so then this becomes really a dimensional analysis problem. So if we have 50 liters of oxygen, O2, and we'll go ahead and say for every 1.43 grams for every 1 liter. 1 liter of O2 will give us grams. And now we have to convert things into moles using our stoichiometric equation and our stoichiometric coefficients. So first off, we want to figure out how many moles of oxygen this is. So we know based on the periodic table that oxygen weighs approximately 16 grams per mole, and this is diatomic, so we'll have 32 grams of oxygen will give us 1 mole of oxygen. And then we can see based on our balanced stoichiometric equation that for every 3 moles of oxygen, got that guy from right there, we'll produce 2 moles of potassium chlorate, KClO3. And then it's asking for how many grams must we decompose. So potassium chloride is a salt, so we're going to want to know it in grams in order to weigh it out on our lab balance. So we're going to have to go and figure out the density. So you can just Google this, or you can use the periodic table. So molecular weight of potassium chlorate. And we see that the molecular weight of potassium chloride is 122.55 grams per mole. So 120, I'm just going to go round it and just say 123 grams of KCl3 for every 1 mole of KC. Oh, sorry, got this backwards. So for every 1 mole of KClO3, we're going to produce 122.6 grams of KClO3. And so we go ahead and plug this in our calculator. So you multiply everything on the top. So we got 50 times 1.43 times 1, I'm just going to leave that out, times 2 times 122.55. We'll actually write it all out. Divided by 1, we'll leave that, divided by 32 times 3, and then times 1, and we'll leave that all out as well. And again, if you wanted to find the molecular formula of this, you'd go to the periodic table. So oxygen is 16, chlorine is 35.5. I'm not sure what potassium is. It might be 20. And then we go ahead and plug this in our calculator. Our calculator right here. And we go 50 times 1.43 times 2 times 122.55. And then we'll divide that by 32. And then we'll divide that again by 3. And so we'll get 182.5484375. So we don't need that many sig figs. So we're up here. We got 3 sig figs right here. And that means we'll end up with 3 sig figs because we're dividing. So in reality, we're going to need 183 grams of potassium chlorate, and this is going to be our final answer. So that's the amount of potassium chloride we'll need to produce 50 liters of oxygen at standard temperature and pressure.